Recording is on. Day 26. So yesterday we talked about classes and objects and constructor functions. Today we will talk about object oriented principle. Object oriented principles. So yesterday we talked about you can say classes and objects. Now we will see object oriented principles. Okay. So when you talk about object oriented principles, is a programming paradigm that is centered around the concepts of object. Object means car object, animal object, human object, and anything like that. Correct?
Yes.
So when you say pillars of object oriented principles, there are 4 pillars: encapsulation, inheritance, abstraction, and polymorphism. So there are 4 pillars of object oriented principles: encapsulation, inheritance, abstraction, and polymorphism. These are 4 pillars of object oriented principles. What is object oriented principles? A programming pattern that is centered around the concept of object. Objects represent the real world entities and are the instances of classes which serves the blueprints or the templates. Yesterday we have seen classes are nothing but what? The templates, and objects are the real world entities. The object oriented principle is designed to organize the code in a way that object is designed to organize the code in a way that models the structure and behavior of entities in a program. So when you say car, there is a requirement, and then you have created a car. Similarly, there is a requirement of road. Similarly, there is a requirement of other things. And so you will design a whole system around the objects, different objects. Consider a game. You need to create a city in a game. You will create car object, human object, shop object. Everything would be represented in the terms of object. Now, what do you mean by encapsulation? So encapsulation is one of the 4 fundamental principle of the object oriented programming, and involves building the data, that is the attribute, and methods, that are the functions, that operate on the data into a single unit called as class. This concept aims to hide the internal details of an object and expose only what is necessary for the outside world. So encapsulation provides several benefits Encapsulation provides what? Several benefits. Now, let's code it. New file. And here we can say app01.ts. And here I can say class vehicle, or let's vehicle class car. Into that we will have private speed is of type number, private make is of type private model is of type string, and private manufacturing is of type date. And then you can have a constructor. Then you can say speed is of type number, make again is of type string, model is of type string, and mfg is of type date. So this dot speed, this dot make is equals to make, this dot model is equals to model, and this dot manufacturing is equals to manufacture. This is the car, right? Now when you talk about encapsulation, encapsulation is one of the 4 fundamental principles of object oriented programming and involves bundling the data. See, bundling is important. Bundling the data attributes and methods functions that operate on the data into the single unit called a class. So this concept aims to hide the internal details of an object and expose only what is necessary for outside world. So encapsulation provides the several benefits including data protection, modularity. Now what encapsulation is saying exactly? So this access modifier, so encapsulation says that if you remove this private from here, and here we can say const c is equals to new car, then we can speed this, make AAA, model BBB, and new date. Now see, this is a built-in object, date object, built-in thing. Now if you see here, from this object c dot make, this shouldn't happen. Now if you see a bundling, what is that? It involves the bundling the data and its methods that operate on the data into the single unit called as class. This concept aims to hide the internal details of an object and expose only what is necessary to the outside world. So this is a breaking of encapsulation, right? So for that you need to have one method, public. You don't need a public keyword. Set make, and here you can say make is of type string, and here you can say this dot make is equals to make. And all these things need to be private. Nothing should be accessible directly. Nothing should be accessible directly. Am I making sense?
Yes.
That is what the encapsulation is. Right? Now, if you want to, so this is not allowed. C dot set make. VVV is the make. And this is what is called as encapsulation. First principle. So what happens if you have encapsulation? Encapsulation, we have seen that. So encapsulation provides the several benefits, including data protection, modularity, and the flexibility in the design. So data hiding. Encapsulation hides the internal state, meaning that the details of how data is stored and manipulated are not directly accessible outside the world. This helps to prevent the unauthorized access to the internal state. Access control. Access to the internal state of an object is controlled through use of the access modifiers, that is the private, right? Modularity. Encapsulation promotes the modularity by organizing the related data and methods into the single unit. This modular structure makes it easier to manage and maintain the code, as change to the one part of the system are less likely to impact the other part. Flexibility. Because the internal implementation is hidden, changes to the internal representation of the data or the implementation of the method can be made without affecting the external code that uses the class. So if you change, now see meaning of this line, if you change something like this, now see you have made some change in an internal method which will not affect outside the class. So this line would be same as it is, but something is changed internally, correct?
Mm-hmm.
Okay, this is about the encapsulation. Let me create.
With data types are written in that case, right?
See, data types, whenever you define the car is rigid in that manner. You are not allowed to change the data type all of a sudden, which means that there is a fault in the requirement.
Mm-hmm.
So when you say car means all these things.
Mm-hmm.
So technically, in an object-oriented modeling way, changing this to the boolean, which is a fault in the requirement. And there are something called as solid principles. Solid principle says that existing classes are open for S stands for single responsibility, O stands for open for extension, closed for modification. You can extend this thing, but you cannot modify this thing, right?
Mm-hmm.
So these are the one of the solid principle I just have said. So encapsulation. Next is what inheritance is. What is inheritance? So let's have a class BMW extends car, BMW extends what? Car. Now what do you mean by this? You are creating BMW from the car. You are creating BMW from what? Car. Car class, which defines is a relationship. BMW is a car, which means that BMW can have all the things that car is having, all the public things that car is having. So here you can say const BMW1 is equals to new BMW, and can you say automatically speed make from where this is coming? You didn't write any constructor in a BMW, but it is getting inherited from the car. 100 make RRR model MMM and date, new date. And here you can say BMW1 dot set make. Now BMW can have its own properties. BMW can have its own properties along with the car properties. BMW can have its own properties, and here we can say cruise control and boolean, or okay, cruise control and boolean, and this can be private. So constructor we would be having, and into the constructor we will have boolean, and here I can say this dot cruise control is equals to cruise control. Why? What happened? And now see, there is an error. If you don't define the constructor, it will take from the parent. Hello?
Yes, I'm
Yeah. So if you don't define the constructor, automatically it will copy the parent. But if you define the constructor, it is asking what about these parameters? Because whenever you create the object of BMW, automatically object of car would be getting created, right? And that's why here comes something called as super, calling the parent constructor. So along with all the details like speed, we need to take from user, number, then make, model, and MFG is of type date. So here you need to pass speed. This is super means what? Calling the parent constructor. Make, model, make, model, MFG and MFG. And here you need to pass one more parameter, cruise control. Yes, it is true. And this last cruise control will be like this. So just for understanding purpose, I'll hit enter over here, 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 here. Just for understanding purpose, right? Sorry. Is that clear?
Yes. So basically, in class, if there are variables defined, we need to compulsory follow this.
Yes,
Define them.
correct. If you can say, if you need to initialize the state of, if you need to initialize the state of the parent, you need to do like this, super call. Even if you want to call one of the parent method, so here we can say set make, and if you want to call the parent method this dot set make, so this will call this method. And if you say super dot set make, so which make method it will call? So here I need to make two uppercase or two lowercase, one change, and inside this something like this. So if you want to call the parents method, what I'm saying, if you want to call the parents method, if you want to connect with the parent, there is one keyword called as super, right?
Yeah. So super is a function of the
Keyword. If you see super here, you have used for defining constructor. Here, if you see the super, here you have used super for connecting the parent, calling the parents method.
Okay, so line number 36, super with the parent class
Constructor. This is
construct.
parent constructor. Clear or not?
Yes, yes. Yeah.
Okay. Okay. This is called as inheritance. So inheritance is one of the four fundamental principles of object-oriented programming. It allows a class known as a subclass or derived class to inherit the properties and the behavior from another class. Properties and behavior from another class, right?
Yes.
Now, the parent class is also known as superclass or the base class. This concept promotes code reusability, modularity, and the creation of hierarchy of the classes. The key aspects of inheritance include base class, derived class, code reusability, method overriding, and access the superclass member. So if you see method overriding, so set make is defined in super, but I have redefined in the child, that is the BMW. Set make is already defined in the parent class, but here I have redefined it. Well, this is something you don't need right now. Just as an example, I have shown you how do you call the parents method in this way, super. Okay, but this is called as overriding. Overriding the parent's behavior. Parent is setting make in some different way, but while BMW wants to set the make, cruise control need to be considered. That's why you are overriding the parent's behavior. Base class, the base class or the superclass is the class that defines the common properties and methods shared by multiple classes. It serves as a template for creating the subclasses and encapsulates the common characteristics of the related objects. Base class, the commonality related to the car, everything we will write it into the car. If you want to define the car, that common things would be in a car, related to the car. Derived class or a subclass is the class that inherits the properties and behaviors, both the things, from a superclass it can extend or modify the functionality of the superclass, and it may also have the additional properties like this. Cruise control is not available in a car, but it is available in a BMW. Code reusability. Inheritance facilitates the code reuse by allowing a subclass to inherit the attributes and the behaviors of the superclass. This avoids the need to duplicate the code. Reusability. So you don't need to write these things again and again. Just extend it and those things are available. Just extend it and those things are available. Method overriding. Subclass can redefine methods inherited from the superclass. This allows a subclass to provide its own implementation of a method while maintaining the overall structure defined by the superclass. Right? Access to superclass. Access to the superclass members using the super keyword. You can access here constructor, and here we have access the methods. Okay.
Yeah.
Now abstraction. So let me create new file, app02.ts. I'll be back in a minute. Yeah, okay. So abstraction, interface, shape. Into the shape, what we'll have? Calculate area. And which will return the number. Now class triangle extends. Is it correct? Extends? Hello?
Yes.
Or let's make class abstract class shape. Abstract class shape. And abstract method extends shape. Earlier was not correct. I will come back to that point. And then class circle extends shape. All these are the shapes. Now see, shape is taking, this is the actual shape. This is what? Actual shape. Shape is having some area, calculate area. Triangle is also shape, and circle is also shape. Triangle is also shape and circle is also shape. Spelling is wrong. This is shape and this is shape, means shape is taking different forms. Now here you need to override the method calculate area. Now see, for the triangle there is a different formula.
Yeah.
And for a circle there is a different formula.
Right.
For a triangle there is a different formula. Now when you say triangle, it would be having two things, B number and H number, correct? B is of type number. As per the encapsulation, these two things should be private. H. And from here we need to return 1/2 into B into H, correct? This dot B and this dot H. Now here radius is of type number, and here you can say return 3.14 pi into R, or just make R, this dot R into this dot R, correct?
Yeah.
In the constructor we can define R. So here we can say this dot R is equals to R, and just call the super empty constructor. Here also constructor B is of type number, and again H is of type number. So here we can say this dot B is equals to this B, this dot H is equals to this H, and first line should be the super call. Give a call to super. Give a call to what? Super. Now if you see, circle is extending to the shape, triangle is extending to the shape. Now what do you mean by abstract class? I'll give you one example. Yesterday I saw an animal. Yesterday I saw an animal. So can you create this picture in your brain? Can you create picture of animal in your brain?
Yes.
How?
I mean, animal is like 4 legs. I don't know the exact animal, but 4 legs, 1 tail.
Okay.
I can imagine.
Yeah, but something is incomplete.
Right.
You are not.
Means that is wild or pet animal.
Yeah, correct. And that's why there are some requirements are partial,
Yes.
right? And that partiality is represented in the abstract keyword. Means you cannot, the way your brain cannot create object of animal, you cannot create object of shape. See here, you will get an error. Cannot create the instance of the abstract class. What is the reason? Reason is that something is incomplete, and because of this calculate area. So shape I know, but how to calculate the area of the shape, that I don't know, because I don't know exactly shape. For a triangle, a separate area is there, circle separate area, rhombus separate area, rectangle separate area, but here just a calculate area, there is no implementation provided. And this thing is making whole class as incomplete class. This is the incomplete class, and this incompleteness is represented by this abstract keyword. Now who is going to complete these classes? Children. Triangle is a complete or concrete class because we know how to calculate area of triangle. Circle, we know how to calculate the area of circle. So there is no incompleteness in these two things. And that's why if you see const sh is of type shape, right? Technically in TypeScript this will happen. And the shape can be of type triangle. Can you see? That is working. B 18 and 90. Can you see? It's of type shape. And you are assigning it to the triangle. This is of sh2. Again, this is of type shape. And here you can say circle. Right? And then you can call console.log sh1.calculate area and console.log sh2.calculate area. Can you see multiple forms, shape? This is the shape, but it is taking the form of triangle. This is the shape, but it is taking the form of circle. Polymorphism. You getting it or not?
Yes, yes. So here shape is compulsory to write while creating the object.
Not necessary. This right, this one right?
Yeah.
Absolutely not necessary.
Yeah, because you already inherited triangle and
Correct. But just to show you,
yeah.
sh1 and sh2. So it will look like this.
So how it flows? I mean, can you tell me the flow?
Flow as in?
What exactly happened when you created the object sh1 and
It's of type shape.
yeah.
Then
So sh1 is created actually of type triangle, right?
yeah, but see, object is of type triangle, reference is of type shape. That is possible. Object is of type, so here you are creating object of triangle. So if you go to the constructor of triangle, what is happening in the beginning? You are creating, you are calling a parent constructor, that is nothing but what? Shape. This constructor you are calling over here, which means that whenever you create the object of triangle, it is containing the object of parent.
Right.
And that's why this line is true. So this is the bigger box. Triangle is both the things, inheritance. Triangle is shape plus its own properties. And that's why this equation is true.
Okay, so if you are saying polymorphism,
Mm-hmm.
you are considering the parameter sets to the object, or in which sense you are saying polymorphism here?
So here SH1 is of type shape,
Mm-hmm.
but which form it is taking? A triangle form. Here also now see both the things are same. Here is also SH1 is of type shape, and this is also of type shape. But look at the object. Objects are different. These objects, these objects are one from the triangle, another from what you can say circle. Two different things are happening over here, but they are representing the shape only. They are the representations of the shape only. No matter it's a triangle or it's a circle, what they are representing? They are representing shape. And why we are saying they are representing shape? Look at this. Triangle extends the shape, circle extends the shape. What is the shape? Shape. What is the shape? Shape is an abstract class, which means that there is a incompleteness in the class. What is incomplete? How to calculate the area? We don't know how to calculate the area of shape. But when we say how to calculate the area of triangle, it is known to us. When we say how to calculate the area of circle, when we say how to calculate area of the circle, we know exactly. You got it or not? Polymorphism.
Yes.
One object is taking different forms.
Can you just open the last triangle? Or,
Any question?
so in abstract class, like we define the concept. So what else we can define?
Abstract class, whatever you can do in a normal class, all that things are possible in abstract class. Just one thing, you cannot create the object of abstract class.
That.
Yeah, directly object you cannot create, but via children you can create the object. Correct?
Yes.
Clear? Any other question? All things are possible in abstract class. Just one thing is not possible. You cannot instantiate the abstract class.
Ideally, abstract class have a function. Ideally,
Not required.
You can
See, if you want to stop the instantiation of the class, you make it abstract. But in the object oriented modeling, if something is incomplete into the class, that class should be incomplete. You got it?
yes, and polymorphism also talk about this thing, function. Uh, I mean, functions with same name
Yeah, see here.
and different types.
That is the overriding.
Yes.
So polymorphism is one of the four fundamental principles of object-oriented programming. It allows objects of different types to be treated as the objects of a common base type. This concept enables the code to be more flexible and extensible as it allows the single interface to be used. I will come back to this point for the different types of objects. So presently here you can consider shape. Shape is used to create different objects. That's what they are saying here. So this can be well implemented by means of abstract class. We'll see that tomorrow. Compile time polymorphism. JavaScript is a dynamically typed programming language, meaning that types of the variables are defined at the runtime. As a result, compile time polymorphism, where the method or function, okay, so now I have a method, function, show area. Now to the show area, it can go any shape. So here I can say sh is of type shape, and I can simply call sh dot calculate area, return sh dot calculate area. Now see, I can call show area and pass sh1, which is of type, which is holding the object of type triangle. If you can make it triangle, and if you can make it circle now, and show area sh2 here. Can you see here you are saying sh1, here you are saying sh2. sh1 presently is of type triangle, sh2 is of type circle. Now which object is here? See now, as a result compile time polymorphism, where the method or a function to be called is decided at the runtime, is not explicitly present in the JavaScript. So here in the JS this is not available. Runtime polymorphism, JavaScript primarily exhibits a runtime polymorphism where the method or a function to be called, which method or a function to be called, see here, which method or a function to be called is decided at runtime, because we don't know which object is coming over here. That's what the runtime polymorphism is. And compile time calls are decided at compile time, and calls are decided at runtime. That's the runtime polymorphism is.
So here you pass in the function the parameter is sh, right? Type shape. So actually you're creating object of shape mask.
Where?
Line number 40.
No, is a reference. sh1 is equals to, it is like this only. If you say shape, sh1 is of type shape and new triangle. Can you see? Same thing is happening here. Reference is of type shape, but the object is of type triangle. Same thing is happening over here. You getting my point or not?
Yes, yes, I'm getting, I'm thinking about it.
Okay. Now this is the polymorphism we have seen. Now abstraction. You can consider this. You can use this code for understanding the abstraction also. Abstraction is one of the 4 fundamental principles of the object-oriented principles. It involves simplifying the complex system by modeling the classes and essential properties behavior they share while ignoring or abstracting away the unnecessary details. Right? The goal of the abstraction is to provide clear and concise representation of the real world entities, right, in a program, and making the code more manageable and understandable. That's the normal. Identifying essential features, creating the abstract classes, hiding the implementation details, promoting the modularity, enhancing the flexibility. So abstract, so here if you can see, sorry, identifying essential features. Abstraction requires identifying the essential features of an object or a system while omitting the irrelevant details. Only needed we will keep. So in a shape, calculate area is needed, we'll keep only calculate area. This involves focusing on the important for the current context or the problem domain. Creating abstract classes, we have seen that. What do you mean by exactly this? Hiding the implementation details involves hiding the internal implementation of a class from the outside world. Users of a class should interact through the well-defined interface using methods and properties. You are not allowed to access directly properties. You are not allowed to access directly properties, but you should have a sophisticated methods to access them. Promoting the modularity. By abstracting away the unnecessary details, code becomes more modular and easier to manage. Abstraction allows for the creation of the self-contained reusable components. Same thing. Enhancing the flexibility. Abstraction enhances the flexibility of the system by allowing changes to be made to the implementation of the class without affecting the code that uses it. Which means that if you change the method calculate area, it should not impact here. Internal details need to be changed. Abstraction, more specific. Instead of creating simple class, just make it as abstract class. Hello?
Yeah. Yes.
So I will push this much code.
Yeah.
Typescript. Encapsulation. Inheritance. And abstraction. I have pushed the code. You may check it. I will upload the recording also. Let's call it for a day. You can revise it and you can ask me questions tomorrow. Okay?
Yes.
Yeah. Thank you.
Thank you.